Okay. So we're getting into chapter 4.
Holy shit.
By the way, just so you're really aware of this, I kind of give chapter 3 its own little double quiz because chapter 3 is sort of like a standalone chapter in a lot of senses. So it's not going to be on test 2. Probability will be on the final. Oh yeah. You know it. Is everybody with me? So we're going to have that double quiz on chapter 3, and the next test is going to be 4, 5, 6, and 7, I think. A couple of those have 2 sections in them, so be quiet. All right. So chapter 4, all right, so chapter 3 is very kind of just general ideas of probability. Chapter 4, we're going to come back to something very specific. How have I given you data up until this point? As a what? How have I given you data? Yeah, okay, but like in chapter 2, when we had to do a mean, median, standard deviation, I just give you a list of data, right? Isn't there a better way if there's a lot of repeats in my data? So if I said there were 4, let's just say I have data that looks like this. 1, 1, 1, 1, 2, 2, 2. That's just 3, Jeff. I like it. That's a good start. 3, 4, 4. What is that? 1, 2, 3, 4, 5, 6. That's beautiful. Right. So I give you this list today. There's a lot of repeats in there, right? I'm about to show you why the math we're going to do makes sense. So you're never going to quite do what I'm going to do right now. But it's important to see why it makes sense what we do. So I always got to describe that for everybody because somebody's like, well, what are we going to do? Oh my God. All right. So instead of doing 1 plus 1, let me do like this. Let me be like really smart. There's 4 1s plus 3 2. So what am I calculating right now? Eventually. I'm going to add them up and I'm going to get the mean. So 4 1s, 3 2s, 1 3, and 2 4. So what am I going to divide it by? 10, because it's 10 freaking numbers, right? Now just please stay with me. How big is this list of data? Small as all shit. So yes, we can do this and finish it out, but I'm going to show you an alternate way to look at this that will then handle lists of data that are millions of data points. Are you with me? Millions of data points. Do you want to do this? You can do it. Go, feel free. The rest of us are going to do something much quicker, right? So I could, just to show you, this is a valid but old way. It's just to actually do this shit. What's 4, 10, 13, 21? So I get a mean of 2.1. Is that cool? And that's good because it's the smallest data. I can do this, no big deal. But an alternate way to look at it. The math doesn't give a shit when I divide by 10, as long as I actually divide by 10. What the hell do I mean? Can't I write this as 4 tenths times 1? Plus 3 tenths times 2. Plus 1 tenth times 3. Plus 2 tenths times 4. Is that any different? No, they all have an LCD. I could put them all back together. If I could put things with an LCD together, I should be able to tear them back apart. Right? Do you remember doing that with like in algebra? What's the slope of this? Or what's the y-intercept? Well, if you broke it up, then you can see everything, right? That's all I'm doing. But again, how often are you going to have to do what I'm doing right now? Never. I'm just showing you why what we're going to do makes sense. What's 4 tenths? Isn't that 40%? 0.4? That's 30%. That's 10%. And that's 20%. How does that relate to my original list? What percentage of the original data is 1s? 40%. So 40% 1s plus 30% 2s. And I know, you got to stay with me. Some of you guys are like, why the shit? My God, we're done over there. Did you see, Jeff? We're done, right? But again, small list, easy. This is going to be easier for billions of data points. So what do I get here? I get 0.4 plus 0.6 plus 0.3 plus 0.8, right? 1.3 plus 0.8 is 2.1. Same stupid answer, of course, because it's the same math problem. Now, how does this relate to anything, Jeff? Please, dear God. Here's a way. So now, here's how we're going to get data. This is how we're going to get data, and this, what's called a probability distribution. When I call this relative frequencies, which is really what percentages are, which probabilities are, we call it a relative frequency distribution, remember? So now I'm looking at this as probabilities, so I'm going to call it a probability distribution. Ooh. So that's the title of the section, probability distribution. What's got to be true about a probability distribution? All these have to add up to be 1. Or close if I rounded somewhere, right? We should be used to that. So if you get 0.9999, don't say, it's not valid. I don't have to do anything. Shut up. That's close enough to 1. And just to warn you, I will do that to you on the test, on the next test. I will do that exact thing to you. Okay. So it's a probability distribution because, how do I write this really quick? When I add up the probabilities, I get 1. What symbol do I put right there? Add up all. Yes. When I sum them up, I get 1. Now the next thing's kind of dumb, but you got to check it. Right? What's got to be true about each probability? They each have to be between 0 and 1. I have a handout, which you should probably know, that's got a lot of this stuff on it already. It's got one side that's all worked out, and the other side I'm going to make you do. Right? Method to the madness. Yes?
Is it an equal sign next to 0?
No, it's less than or equal to. So the probabilities have to be between 0 and 1. That's the right way to read that. You guys all right? I love the look on some of your faces. What's going on? You're like, what have I done to myself? Oh, you signed up for it. So here's how the math we're going to do. Now, real quick, if I give you this, I don't give you this at all. I just give you this. Can you tell me how long the list of data is? No, you can't. All I know is that 40% of the data is ones. So there could be 1,000 data points, and 400 of them are ones. And you'll see a problem in a minute where you don't want to convert this back to a list, because that would be a long freaking list. All right, so stay with me. So what's the math going to look like now? Well, what did I do to get the mean here? What is each of these? What is this and this? What is 0.4? Probability. And what's 1? The data point, x, right? So what's each of these? Each of these is x times p of x. X times p of x. Right? So I'm going to make a column that's x times p of x. That's crazy. So I'm going to multiply, and then I'm going to add, and that's going to give me the, what was this? Mean. The mean. It's going to be a beautiful little formula for mean. Oh. So what I get, 1 times 0.4 is 0.4, 0.6, 0.3, 0.8. God, Jeff, she called me. When I add those up, I get 2.1. That is the sum of x, p of x. So the formula for the mean, if I give you a table with x and p of x, is the sum of x times p of x. Now you read, this is really, really, really cool. This is insanely cool. For me, so maybe slightly, almost, not really, sort of on the boundary of cool for you. Another name for the average is the expected value. Think about that. Doesn't that sort of make sense? The average should be what I expect to happen over a long period of time, right? What are the first 3 letters in this formula? Looks like an E. X. No. What are the letters? Looks like an E. X, P, expected value. All right, some of you guys, I appreciate some of you guys going, oh, okay. Humor the old man. That's neat, Jeff. Come on, that's awesome. It's expected value, so it's got the first three letters of that word in the freaking formula. I mean, come on. Hey, sorry, I'll let it go. How are we doing so far? I mean, I desperately want you to see, this is just why doing that third column works. Isn't that really nice? Is that difficult? No, it kicks ass. There should be a quicker way to do this shit when there's a ton of repeats. So instead of representing like this, I can just represent it like there's 40% ones. I'm not going to write the list for you, shit. All I need to know is 40% of them ones. And if I write it like this, there must be a quicker way to figure out the mean. Now, what's the normal mean formula? What does the mean formula just look like for a list of data? Yeah, sum of x divided by n. So what looks like it's missing in this formula? But what's on the bottom of a probability? What's always in the bottom of a probability? Total number, n. Holy shit. So it's the same stupid formula. Right? Isn't that nice? Well, it is to me. Okay, I'll get past it. All right, now what's going to be a little more disgusting? Of course. What else do I need to calculate? You've got to know there's two things I want to calculate anytime I have a distribution that I'm given. What two things do I need to calculate? The mean? The mean, which measures the center. Standard deviation, which measures the spread. Those are the two most important things to know for a quantitative group of data. Is the mean, where's the center, and the spread, the standard deviation. Those two numbers give me a really quick feel for what it kind of looks like and how it kind of works. You guys all right? So every time we encounter a new way of giving me data, another distribution, what are we going to do? We're going to figure out how to get the mean, how to get the standard deviation. Because those are the two most important things. So let's do the standard deviation, then we'll take a break. Okay. Now, you're going to have to, your notes are going to be interesting on this, but I won't. Notice how, to get the mean, normally I would just add the x's and then divide by n. But now what do? I multiply the things I was going to add by the probabilities, right? So what do I normally do to figure out standard deviation? I would do this. So for a mean, I would do this, but what do I have to do now? I have to multiply these by p of x. Because it's already got the over n in it. Are you guys kind of with me? So here, what am I going to have to do? I'm going to have to take these and multiply by p of x also. Same idea. That p of x is like a weight. So what would the average of 1, 2, 3, 4 be just by itself? What's the average of 1, 2, 3, and 4? The average. I love you guys. 1, 2, 3, 4, what's the average?
2.5.
2.5. What was our average? Why was it lower than 2.5? Because what are there the most of? Ones. So the heaviest weighted thing is where the mean gets drawn towards. So that's why this is also called the weight of the value. Okay. So here, if I take all of these guys times the weight, and then add those up. Now, how many more columns would I need to do this? If I do this, how many more columns? Can you imagine? I need like at least 3 more columns. F that. But I'm going to show you how to get one more freaking column. It's going to require a little bit of algebra. Right? Should not be a big deal because you've all survived algebra. If you see this in algebra, what's your instinct? Yes, do it. I don't know why I'm yelling at you guys, but oh well, it's happening. Do that. Now, how often are you going to have to do this in a problem? Never, besides right now. So just do it, get it over with. I'm going to create a new formula that's better, that's quicker, stronger. We have the technology. You all right, Mike?
Yeah.
Yeah. Oh shit, do you guys remember how to do this?
X squared minus
Yeah, two of these, right? 2 mu x plus mu squared. All right, now, I'm not going to go through every step. I just want you to at least see where the first piece of this comes from and makes sense. This is not summation algebra class. I can make it into one, but I don't have the time. Just go with it. So let me bring back the other pieces of this statement. So I get sum of this times that. Now this is where some of you guys just kind of tune out. Please, dear God, you never got to do this shit yourself. Just kind of watch. I just want you to see where the formula parts come from. How does this relate to this?
This is broken down.
It's the same thing, right? Just like 2 plus 5 is 7. I wouldn't say 2 plus 5 is not 7. Look at all those parts over there. They're both freaking 7. All right, I like it. So this is the same as this. So if this is what I need to calculate, doing this would work too. Now, right now, you look at this and go, good job, Jeff. You made it worse. Thanks. Yeah, that looks much worse. But now watch. I would distribute this next, right? I'm not going to do this whole, don't worry. So what would I get first? I would get x squared p of x, right? Now what's really interesting, I'm not going to show you this. I just am not. But if you do the rest of this shit, remember what mu was? Mu was sum of x, p of x, and all this kind of business, and you bring that in, you end up getting this. That's all it is. That becomes this. So all the rest of this shit all goes together and becomes just this. If you really want me to, I can write this out and give you copies of it, or you can just accept that as true. So what does this mean? If I need to calculate this, and it would require a lot of freaking work, I could instead do this because they're the same. They're the same formula, just reorganized. I like some of you guys are like, how did he get there? Well, I'll try it. And I could show you if you're interested. So what does that mean? Look, real quick, first off, do you see how that's separate? So if you cover the summation symbol, what column do I need still? Do I have that column yet? I need a column of x squared p of x's. So I just need one more column. So even if you didn't quite follow, which is fine if you didn't, because this is the variance formula that we're going to use. This is the conceptual formula. This is the calculation formula. What does standard deviation always have to have in it somewhere? A distance from the mean to the data points, because that's what standard deviation is all about. This one lost it, didn't it? I don't see that shit anymore, but it's an easier one to use. All right, so let's try this out. How do I get that column? What would I do? What I do, just to tell you, is I take L1 times L3, meaning this column times that column. You guys see how that makes x squared p of x? What's x times x p of x? X squared p of x. You could also square this dude and multiply by this dude, of course.
So you take L1.
Yeah, L1 times L3. Right, and again, it's going to be on this handout I'm going to give you. Okay? So let's try it. 1 times 0.4 is 0.4. Wow. 2 times 0.6 is 1.2. 3 times 0.3 is 0.9. 4 times 0.8 is 3.2. So instead of like multiple more columns to do this, I just needed one more column. I really want you to see the utility. What do you get when you add those up? 5.7? 5.3, 2.5, yeah, 5.7. Now how do I figure out my variance then? Where's that? It goes into my formula. Minus the mean squared. Right? So a lot of people just take that number and square root it. But no. There's the formula for variance. That's just one piece of it, right? You guys semi with me here? A little tiny bit? Not much? Barely, Jeff? Okay. So the variance here would be the sum of these minus the mean squared. So the sum of these was 5.7. What was the mean? 2.1. So somebody help me out. 2.1 squared is 3.7? No, that can't be. That doesn't make sense. I'm way off. What is it? Why was? Oh, I did minus instead of 2.1 squared?
You're giving me the final answer.
I know. I'm curious about this now. Plus 1, so 4.4, 4.5, 4.41. There's. I keep going the wrong decimal place. So then I get sigma squared is, 1.29, and then so what's sigma? What's the standard deviation? 1.135?
Or 6.
1.136? Okay, let me give you this handout. I'll let you look at it real quick, and then we'll take a break. On the back side is the parts I want you to work on, okay? So if you're one of those people that don't want to take a break, you can just get that knocked out. You guys want to take a break right now, or you want to do this first? All right, let's take a break. If you want to do it, you can stay here and do it. Sing it. No, the quiz tomorrow is only chapter 3.